This is the iLab for week 3. In this particular iLab, we're going to be diving down and looking at very closely a social media analysis. That's basically, that's how do you look at the results of all the various types of social media. It could be it Facebook, be it LinkedIn, be it Twitter. There's any number of different social media that are out there. And their activities generate what in essence is a network of information. And the subject for this iLab is about how do you analyze that particular network. We're going to do it in 3 major parts. The first one is we're going to look at social network analysis in general. Then we're going to introduce you to a tool called NodeXL, which provides a very powerful set of analyses that can be done on networks. And NodeXL is just nothing really more than an Excel template that you install. And then after we're going to use Twitter as a Twitter feed as an example. And then after that, we're going to ask you to analyze another data set and interpret the results of that analysis. If you look at social network analysis, we're going to do 2 main videos in this part of it. This is the first one you're looking at right now. We're going to look at an overview of what networks are, some terminology, and a bit about how you measure them. And then we're going to look at network analysis and why it's valuable and for what sorts of things, and social media networks in particular. So if you look at networks, a network is defined as consisting of two main things. The first is something called nodes or vertices. They're used interchangeably depending upon who it is you're reading and working. So we'll use them interchangeably in this iLab as well. And a node is just the thing that you're interested in, its behavior, collecting it. So, for example, if you look at an organization, one of your nodes might be the people within that organization, and arcs are just the connections between the nodes. So one connection might very well be, that just that someone knows someone else type of connection. And then there's different types of networks that we're going to take a look at, how you represent them, how you can look at them from different points of view, and how you measure them. So we'll be looking at each of those. And when you're considering networks, you typically partition them into 2 major different kinds. One of them is called directed, and that's when the nodes in the network, the direction of the connection is meaningful for some reason, and undirected, the connection is not meaningful. So if you look at a couple of examples here, we have a directed network, and the connection is defined just by the word supervises. So if you look at a diagram of this, you'll see that Martha supervises Hope, Martha supervises Evans, and so forth. And it's directed with this the end of this arrow points to the direction of the connection. If you look at this same set of nodes, but maybe the connection is defined by knows instead of supervises, so that one person just knows somebody else. And in this particular case, we have Martha knows David, doesn't supervise him, but certainly knows him. And if you look at the pattern here, you can even visually, you can begin seeing some interesting things. Say, for example, David is obviously pretty well connected, even though he's at the bottom of the organization chart here. He's a pretty well connected individual. Evan, on the other hand, over here, doesn't seem to, doesn't seem to know, has no direct connection with Frank, except somehow through Martha or through Hope. In some fashion, he doesn't have a direct connection in any kind of way with Frank. So it's a kind of an interesting organization chart, even for a small organization. And you can see a lot visually if you just look at it, networks. And we'll look at that a little bit later when we use the NodeXL tool. So that's the types. If you look at more specifically about types in general, there's egocentric, where there is a single node and everything is connected, every other to which every other node is connected to. You can have a full network or partial. You can also have different kinds of nodes as opposed to having a single kind in a unimode. And also you could have different kinds of edges or connections, if you will, arcs to the nodes themselves. So diving, again, opening up and getting a little more specific, If you have a network that only includes nodes, they're called alters, that are connected to a specific individual. In this case, it's called the ego. It's called a 1-degree network, and if you are looking also at not just the connections between the alters and the ego, but the connections among the alters as well, then you have what's called a 1.5-degree network. Example is pretty easy. If you're in Facebook, you're the ego in one kind of network, and your friends are the alters. You could also extend this network out to friends of your friends. That would be called then a 2-degree network. And again, if you allowed connections among all your friends of friends, you'd have a 2.5-degree network. But if you start extending networks out very far, it gets to be very, very complicated in terms of the analyses and difficult to see things. So oftentimes what you'll wind up doing is taking a full network and partitioning it into parts and looking at those parts. And that's done a lot. If you consider nodes for a moment, if you have a single type of node, which most of the time that's what we're considering in social network analysis, it's called a unimodal network. You can have more than one type of node in networks, however, and if you have, the most common is what's called bimodal network, where there's one type of vertex that represents the nodes or entities, and another type of vertex represents some other action or content. So, an example, you might have one set of nodes or people, and another set of nodes is a specific message that gets transmitted across some of the nodes there. This is also called an affiliation network, and typically when you begin analyzing this, you'll oftentimes split it into a partial network, one part of which is one type of node and one part of which is another type of node. Just like there can be multiple types of nodes, there can be multiple types of connections or edges here, and we'll look at specific examples of that later on when we are looking at our Twitter and the types of networks that actually Twitter generates itself. You have different ways of describing a network. The most typical way is called a sociogram or a network graph, and that's what this guy up here is. When we looked at, say, for example, the undirected one, this is known as a sociogram or a network graph. You can also do it with an edge list, and here we looked at it. If you looked at the supervised one here, this supervises. Then here's an edge list. We have something called vertex 1 and vertex 2. Vertex 1 always lists the from, and vertex 2 always lists the to if you have a directed graph, which we do in this particular case. And finally, you can also look at it as an example as a matrix, sort of like an instance matrix in a way here. And what we have here, again, we have our sociogram, our vertex, our edge list, and then this is a matrix of this. And we have in 0, it means there is no relationship. But in this particular case, Martha supervises Evan, Hope, and Frank. Evan supervises Lynn, and Hope supervises Jennifer, and so forth. And you can see this is sort of a sparsely populated matrix. In some cases, if you have some of them, some graphs are much more populated with ones than this particular example is. Finally, there's all kinds of all sorts of measures that you can take with a network, and we sort of structure them into looking at them in 4 major categories. You can look at the overall network. These are measures of the entire network itself, as opposed to the stuff that's specific to the nodes or or clusters or other kinds of things. And one of them is a concept called density, and that's just a level of interconnectedness. How many edges connect nodes together if you're looking at it. And an easy way of measuring it is just take the number of actual connections in your network, you divide by the maximum number of potential connections, you get a percentage. So the closer you are to 100%, the more dense that particular network is. Another concept that's important in networks is centrality, and what that means that do nodes have a lot of of connections emanating from them, or are they typically just a handful or a few, in some cases maybe not any connections that emanate from them as well? So you can measure that. You can measure a specific node as opposed to the whole network itself. And centrality in this particular case for a specific node means where that node fits in the network. How close to the quote center unquote is a node? Is it in the center, near the center, or way out on the periphery someplace? For a specific node, you can measure a degree, and that's just a count of the number of connections a node has. You can measure betweenness between two nodes, and that's how far apart they are. And most of the time we use geodesic distance, which is just the number of nodes along the shortest path between any two nodes. You can measure how close two nodes are, and that's the average distance in nodes between a node and every other node on the network. High scores are not very close, and they may even be on the actually edge of the network itself. You can measure the influence of a node. This is similar to the Google's PageRank algorithm, and it measures how important the connections are into a node there, and that's exactly what the PageRank does for Google. And it's called eigenvector also. You'll see that word a lot, and that's just a mathematical way of calculating a number that will provide a sort of an importance measure for a particular node, based on how important the nodes connected to it are. You can also do a cluster measurement, and that just measures how connected together your friends are. And finally, you can look at structures, and that's oftentimes done visually, but you can also do some of it mathematically. What you're looking for there are there patterns within your network that tend to replicate themselves, that you might identify maybe perhaps specific roles that people are playing within or other kinds of entities are playing within the network that you're analyzing. So that takes care of the overview of networks. The next thing we're going to do, but if you look at it, there's quite a bit going on here. It can be a fairly complicated kind of endeavor, and so the question arises, why would we want to do this? And that's what we're going to take up next, and specifically we're going to look at social networks and Twitter in particular as well.